Earth origins.
4,540,000,000 years ago, Earth was a hot mess. Literally. It was a volatile ball of molten rock and metal, kind of like a teenager.
Finally, Earth got its act together as a planet and started to cool off.
Since then, the planet has been shaping and reshaping itself in an endless sequence of geologic, biological, physical, and chemical processes. It's a real shapeshifter, that planet Earth. Don't believe it? Follow me.
Geologic time.
What is geology? Geology is the study of the stuff Earth is made of and how Earth changes. Let's talk about how Earth changes.
Well, the first thing you have to understand is that we can't measure Earth's lifespan on the same timeline as we could, say, a human life.
See, look, here's a human life. Sylvie Applebaum was born, had her first ballet recital, went to prom, stole a famous painting, joined the circus, and received a Lifetime Achievement Award from the local parkour club. Sylvie's whole life is too tiny to even get a little tick mark in the lifespan of Earth. In fact, the entire history of life on Earth is but a blip in the lifespan of the planet.
Picture this. Earth was nearly 1 billion years old before the first primitive forms of life occurred. We're talking single-celled organisms, sort of like modern-day bacteria. It took another 2,700 million years for complex multicellular organisms to evolve. And then it took 630 million years of animal evolution before humans came on the scene. The point is that all of human history is just a tiny percentage of Earth's lifespan.
In order to look at Earth's lifespan as a whole, geologists use something called a geologic timescale. Hey, wait! I said geologic timescale, not catatonic lime whale. That's better. The geologic timescale divides Earth's 4.54 billion year history into distinct intervals of time.
A geologic timescale is necessary for tracking changes on Earth because these changes occur very slowly over a long period of time. They occur so slowly that you can't even see the changes over the span of a human lifetime.
But change things do. Millimeter by millimeter, mountains are built, continents shift, and species come and go. Eventually, Earth is an entirely different place than it was before.
Observing Earth changes through geologic time is a lot like watching this time-lapse video. When we can see a long period of time captured in a span of just a few seconds, we are able to observe major shifts that would have happened too slowly to notice in real time.
One thing that is interesting to look at on the geologic timescale is mass extinction. An extinction is when every member of a certain species dies. At that point, the species no longer exists and will never exist again.
A mass extinction is when many different species go extinct all at once. Mass extinctions can occur for different reasons. For example, global climate change, such as the beginning or the end of an ice age, can cause mass extinction.
You caused mass extinction. You're killing me. Killing me. I'm all over it. You're hot.
Of course, when we say the extinction could happen all at once, we're talking about how it would look on a geologic time scale. On a human time scale, such an event could seem to take forever. It could happen so slowly that we humans would barely notice. But in the grand scheme of geologic time, a mass extinction happens in a blink.
Sudden versus gradual events.
Sometimes changes happen on Earth that can be observed in a human's lifetime. Earthquakes and volcanoes happen suddenly and quickly and change things drastically.
Many scientists today believe that the dinosaurs went extinct as the result of such a catastrophe. But it wasn't just an earthquake or a volcano that ended it for those dinos. The common theory these days is that they pieced out after an asteroid smashed into the planet. This event heated the atmosphere to the temperature of an oven set on broil, ignited Earth's surface, and clouded everything over in years of darkness and debris.
If one of those asteroids were to swing toward Earth today, there would be nothing we could do about it. This is one reason why some scientists would like to expand the space program, so we could get to the asteroids before they get to us. Yikes.